Assalamualaikum and a very good day to all. I'm Arlina Abdul Rashid. I'll be assisting you with the subject of Managerial Economics. So in this course, there are actually 8 main topics. The first 2 topics actually introduces you to the basic concept of Managerial Economics. And then this is followed by a series of theories necessary for this course. This module actually is divided into 14 lectures, and in today's lecture what we're going to do is we're going to look at some of the definitions on managerial economics, and then we're going to focus more on the firm because this is the central focus of this course. And the second part of this lecture for today, we're going to look at the basic training chapter. So the basic training chapter will introduce you to some basic mathematical concepts necessary for this course. As you are well aware of, for this course, there's going to be some calculation involved, along with theories, economic theories necessary for this course. I will start today's lecture by looking at the first chapter, Introduction to Managerial Economics. So as I said just now, we're going to looking at managerial economics definition, and then the circular flow of economic activity, because we would like to understand what is a firm, what are the main roles of a firm, and then after that we're gonna look at the role of the firms in details. So let's proceed with the definition. So when we talk about managerial economics, it is actually an application of economic theory and tools of analysis of decision sciences to understand how firms solve managerial problems most efficiently. So as you can see on the diagram here, so there's for the subject of managerial economics, what we are trying to do is, let's say a firm, they are facing a problems, and this problem can be in the form of, to produce or simply to buy a particular component of your company, or you want to determine the technique of production, or you want to determine the type of product that you want, or even you want to know what is the best mode of promoting your product. So these are example of problems that firms may face. And what we would like to do in managerial economics is we would like to solve this problem using 2 things here, economic theory and also decision sciences. Now if you look at economic theory, it can be divided into 2. So we have microeconomics and macroeconomics. So microeconomics is the study of it is the study of individual units of the economy. So here we are looking at how specific units makes decision. And macroeconomics is the study of the economy as a whole. So we are looking at big issues. But in this course, we are more concentrating on the microeconomic theories as opposed to macroeconomics. And another thing that we're going to look at would be decision sciences. So this is where we're going to apply some mathematical concepts, econometrics. So we're going to combine these 2 things to solve the problems, and the solution that we would like to find would be the optimal solution, or we call it as the best solution. Now, so I hope that by now, so you have an idea what managerial economics is all about. So let us now proceed with the circular flow of economic activity. The circular flow of economic activity actually provides you with a picture of the role played by the firms. So we are only concentrating on a 2-sector model where we have the household and the firms. Okay, so the household, okay, they are the owner of the resources, and they are also the users or the consumers, okay, of goods and services produced by the firms. And firms, okay, so they are the ones who, combine all the resources, okay, and convert it into goods and services. So what we have here in the circular flow model, okay, are two markets. So we have the factor market and the product market. So let's have a look at the factor market first. Okay, so in the factor market, as you can see here, household is the provider of economic resources, and economic resources here comprise of land, labor, capital, and entrepreneurial ability. Okay, so household will provide all these resources to firms, and in return, firms will make payment, okay, for all these resources, okay, to the household. So this payment is an income to the household. Okay, so this is what happened in the factor market. Now let's have a look at the product market. Okay, now in the product market, what happened is that the firms, they are going to use all the resources and convert it into goods and services. Okay, and in return, household will make payments, okay, for the goods and services provided by the firm. So this is what happened in the product market. Okay, so if you look at the circular flow again, so the inner loop actually refers to the money flows, and the outer loops actually refers to the physical flows. So as you can see here, firms play two roles here. Okay, so they are the one who boleh tak nak ambil air tadi? air saya kat atas meja tadi. Sorry. Thank you. Okay, so firms here plays two very important role. Okay, so they are the one, so in the factor market, they are the one who combine all the resources, okay, and then they are also the one who make the factor payments, okay, and in the product market, so they are the one who convert all the goods and services, okay, for the household. Okay, so let us proceed, okay, to the next topic. That would be the nature of the firm. Okay, so we would like to understand, okay, in more detail, okay, what are the role played by the firms here. Okay, so as you look at the circular flow model just now, okay, so firms are the organizations, okay, so that combines and organizes all the resources, okay, to produce goods and services, okay, for the sale of, to sell it to the households. Okay, so why is it important for having firms, okay, in an economy? It's because it's very costly, okay, for individual to enter into each step of the production and distribution process. So just imagine if there are no firm, okay, in the market, so meaning that, okay, all the products in the market must be produced by each individual household, okay, and this is a very costly steps. Yeah. Now, the third one would be the primary goal of the firm. Okay, so as you all know, the main reason why we have firms in an economy is because they want to maximize wealth, okay, or the value of the firm. So when we talk about maximizing wealth, so this is actually referring to the present value of the expected future profits. Okay, but that is not the only goals, okay, of the firm. Okay, so other goals would be to maximize sales, maximizing market share, to produce products that are technologically advanced. Okay, and there are also non-economic goals whereby firm also wants to produce environmentally friendly products. Okay, they want to have an organization that are very conducive for the employees, or they want to provide a very high quality products or services to consumer. So these are also goals of a firm. Yeah. All right. Now, while achieving the objectives of the firms, firm do faces some constraint. So this constraint can be in the form of financial, moral, technological, environmental. It can be resources constraint or also legal. So take for example a company. So let's say we have a company that's producing clothing. So definitely the main objectives of the firm is to get the maximum profit possible. But there are limitations faced by the firm. So what's the limitation? So the limitation can be, for example, they are given only $10,000 to spend on the resources. So they want to maximize profit, but they are facing a constraint in the form of budget. So these are what we call as constraint, financial constraint. Now, the next thing that we're going to look at would be profit. So as you all know, the main objective of a firm is to maximize profit. But what is profit? There are several theories that try to describe profits. So one is that profit is actually the reward for bearing risk. So as you know, entrepreneurs are the ones who have to think about how best to combine the resources, what would be the number of labours and capital that they need to use, and for the risks that they have to bear, they're going to get profit. So profit is actually the reward of bearing risk. The next one would be, it is actually a reward for monopoly status. So a monopoly is the only company in an industry. So being the only company in an industry, so the firm is able to control either price or quantity. So by being the only firm in the market, the firm can get profit in the long run. Profit is also a reward for innovation. So if a company is able to innovate, find the best method of production, or the least cost of producing a product, so the reward that they're going to get is called profit. And the last theory to describe profit is that a profit is actually a reward of imperfect market mechanism. So sometimes there may be a hiccup in the market. For example, there are excess demand in the market. So for that reason, the firm have no choice but to charge higher price, and because of that, they're going to get profit. So these are some of the different theories that try to explain what profit actually is. So what are the main functions of profits? Well, profit serves several functions here. So one of the function is that it is a signal, that the firm needs to change the rate of production. So if, let's say, profit level increases, so this shows that the firm needs to produce more output because demand is increasing. Now, profit also serves as a signal to reallocate resources, due to changing demand and taste. So if, let's say, when you look at the level of profit, there is a decline in profit. So what causes the decline in profit? So you have to look at what's happening around you. So is it because consumer demanding less for your product? So if that is the case, so this is a signal that you have to find better ways of serving the customers. So functions, not only it serves as a reward for bearing risk, or a reward for being innovative, okay, ataupun or it is actually a reward for having a monopoly status, but it serves very important functions. Okay, it signals that the firm needs to change the rate of production, or the firm needs to reallocate their resources. Okay, now, so we have looked at what profit actually is and what are the main functions of profit, but how profit is actually calculated. Yeah, so profit is actually the difference between total revenue and total cost. Okay, to calculate profit, okay, there are two approaches actually. Okay, so the accountants and economics calculate profits differently. Okay, so to calculate accounting profits, okay, they only consider explicit costs, okay, as the cost. Okay, but when you want to calculate economic profit in terms of cost, they include both explicit and implicit cost. Now, let us look at what's the difference between explicit cost and implicit cost. Now, explicit cost is the actual cost, okay, of using explicit cost is the cost that involve actual cash payment. Okay, so for example, let's say to produce a particular product, you need to buy inputs, okay, such as petrol, you need to buy machineries. So the money that you pay to get all these resources is what we call as explicit cost. Okay, now implicit cost is the cost of using your own resources in the production process. It doesn't involve any cash payment. Okay, so an example of implicit cost would be the cost of using your own shop lots, okay, or the cost of using your own utensils or your own machineries in the production process. So it doesn't involve any cash payment. So to measure it, you are going to use the concept of opportunity cost. So to calculate profit, we need to see that there are two ways of calculating it. Okay, so either you want to calculate accounting profit or economic profit. So to calculate accounting profit, it is the difference between total revenue and total cost, but total cost only comprise of explicit cost. On the other hand, for economic profit, to calculate it, okay, you still use the formula total revenue minus total cost, but total cost comprise of both explicit cost and implicit cost. Okay, so due to that, the value of economic profit should be lower than the value of accounting profit, because economic profit includes a more coverage in terms of the definition of cost. Okay, so in terms of chapter 1, okay, so what we have done, okay, for today, we have looked at the definition of managerial economics. Okay, so bear in mind that when we talk about managerial economics, we would like to find out how firms, okay, solve managerial problems most efficiently, and to find the solution, to find the best solution, okay, for this company, we are going to combine our knowledge in economic theories and also decision science tools of analysis, okay, to find the best solutions. And the other thing is that, okay, we also look at the firms, okay, because in this course, firm is our major focus. Okay, we would like to find out, okay, how firms makes decision. Okay, so for that reason, okay, I have also introduced you to the circular flow model, where we are trying to understand the main role of the firm. Okay, so we also look at the objective of the firms. Okay, the objective of the firm comprise of economics and non-economic objective. We also look at the profit, which is the main objective of the firm. Okay, so what's the definition of profit, what are the major functions of profit, and also how to calculate profit. Okay, now before I end today's lecture, I just would like to highlight that now when we learn managerial economics, okay, so this course not only help us to find solution to firms, okay, profit-making firms. But this is also applicable for organizations that are not focusing on profit, okay. So here we are talking about public organization or not-for-profit organization. So the subject of managerial economics is not applicable for private organizations but also for public organization. So for that, thank you. Assalamualaikum and a very good day. We're going to moving on to the second chapter, okay, of the course. So this is where you are going to be introduced with the basic training. Yeah? So in this chapter, what we would like to do is I'm going to show you with some basic mathematical concept necessary for the course. So we're going to start off by looking at functional relationships. Yeah? And then we're going to proceed with economic model, okay, how economic model are being represented. Moving on to types of functions, rules of differentiation, and the last one would be optimization technique. Okay, now we talk about functional relationship. Okay, now a function, it tries to show relationship between dependent and independent variables. Okay, a function can be of two forms. We can have a single variable function or a multivariate function. A single variable function is a function where you only have one dependent and one independent variable. Now, bear in mind that dependent variable is always on the left-hand side of the equation, and independent variable would be the equations on the right-hand side. Okay, so if you have a function with only one dependent and one independent variable, so this function is known as single variable function. The second type of function is what we call as multivariate function. A multivariate function is a mathematical function where you only have one dependent but more than one independent variable. Okay, again, the dependent variable is always on the left-hand side of the equation, while the independent variable will be on the right-hand side of the equation. So when we talk about functional relationship, okay, or mathematical functions, it can be in the form of single variable function or multivariate function. Now, the next one would be economic model. Okay, so as you know, in economics, we deal a lot with a model. Okay, a model tries to simplify, okay, the things that happens around us. Okay, there are various ways to express economic model. The first one is in the form of algebraic equation or mathematical function. Okay, so what we have here is an equation that try to represent the total revenue model. Okay, now the second thing that we have, the second way to represent a model is via a table. Okay, so what we have here is a table that tries to show the value of total revenue for each level of output. So this is another way of representing your economic model. And the last or the final way of representing an economic model is by way of a graph. Okay, so what we have here is a concave down curve, and this is a curve for total revenue function. Okay, so there are three ways of expressing your economic model. Next, we're going to look at the types of functions in more detail. Okay, now let's start with a linear function. Okay, a linear function, okay, is a function, okay, whereby the highest power of the independent variable is equals to 1. Okay, so if we look at the basic, okay, format of a linear function, it is y equals to a plus bx, where y is the dependent variable, x is the independent variable, a is the vertical intercept, and b is the slope or gradient. Alright, so if you look here, okay, what we have here is a diagram, okay, it's a graph, okay. It is a straight line curve. So this is a graph that shows linear function, okay. So as you can see in a linear function, okay, so the graph can be either upward sloping or downward sloping depending on the slope. So on this diagram here, we have an upward sloping curve. Therefore, the slope is positive, okay. And as you can see, this graph, okay, cuts the vertical point, okay, cuts the vertical axis at point A. So that's why the slope is equals to A here. So this is an example of a linear function, okay. So as we, go through this chapter, so you're gonna deal a lot with the linear function, yeah. The second type of function is what we call as a quadratic function. Now, a quadratic function is a function where the highest exponent for the independent variable is equals to 2. So, the basic formula for quadratic function is in the form of y equals to ax squared plus bx plus c. Okay. Now, if the value of a is positive or greater than 0, so the shape of the curve is a concave up curve, okay, with a minimum point. So this is a quadratic function, but this is the case where the value of a is positive, okay. Now, if the value of a is negative, then you're going to have a concave down curve. So a concave down curve will have a maximum point. Now, the third type of function is what we call as a cubic function. A cubic function is a mathematical function where the highest exponent of the independent variable is equals to 3. So, I have an example here. Okay, the function is y equals to 1 over 3x to the power of 3 minus 3x squared plus 8x plus 7. As you can see here, the highest exponent is equals to 3. So this function is what we call as a cubic function. So a cubic function have both maximum point and a minimum point. Okay. And the last type of function is a multivariate function. So a multivariate function is a function whereby your independent variable can be more than 1. Okay, so as you can see here, we have an example of y equals to xz plus 9x plus 3z. So this is an example of a multivariate function. So we have looked at the different types of mathematical function. We have a linear function where the highest exponent is equals to 1. Quadratic function where the highest exponent is equals to 2. Cubic function, the highest exponent of independent variable is equals to 3, and a multivariate function where your independent variable comprise of more than 1. Okay, now once you have been introduced to the different types of function and how a function looks like, we're going to moving on to the rules of differentiation. Okay, so rules of differentiation is very important for this course. Okay, so what is differentiation? Now, differentiation is where you're trying to find the rate of change in the dependent variable when you change independent variable by a very small amount. Okay, so that's differentiation. So another word is that when we talk about differentiation, we are trying to find dy dx. Okay, so this is what you normally deals with, okay, during your secondary schooling. Okay, so when we talk about differentiation, you want to find dy dx or the rate of change of your dependent variable, where independent variable change by a very small amount. Okay, now when you try to find dy dx, or when you try to differentiate a function, in other words, you are also finding the slope of a function. So differentiation also referring to the slope. Okay, now there are 6 rules of differentiation. The first one is the constant function. and then we have power function. The third one is sum and difference. The fourth one is a product of two functions. The fifth one is a quotient function. And the last one is a function of a function. Now, even though there are 6 rules of differentiation, but for this course, you only need to know the first 3 rules of differentiation. This is very important, okay? So you need to remember offhand, okay? But I understand that this is the first class, so most probably you need some time to digest it, okay? So let's look at the first rule, which is the constant function, okay? Now, the constant function rule says, if you have a constant function and you want to differentiate it, the rule says you're going to get 0. Okay, so as long as you have a constant function and you want to differentiate it, the answer must be 0. So as an example here, let's say y equals to 10. It is a constant, right? So if you want to find dy dx, the answer must be equals to 0. Okay, so this is the first rule of differentiation. It's very simple. Okay, let's move on to the power function rule. Okay, now the power function rule is try to show you how to differentiate a function with an exponent. So if, let's say, the general format of your function is y equals to ax to the power of n, where a is a number, x is your independent variable, and n is the exponent. Okay, so to differentiate a power function, what you need to do is, there are 3 steps involved. First of all, you need to bring down your exponent. Okay, so you need to bring down n. The second step, you need to write down the original function, which is ax to the power of n. And the last step, you need to reduce the exponent by 1 unit. Okay, now let me show you an example here. So you have y equals to 3x to the power of 2. So as you can see here, the exponent is 2. So to differentiate this power function, what you need to do is you need to bring down the exponent, okay? And then you write down the original function 3x squared, and you reduce the exponent by 1, and your answer would be 6x. I'm going to show you in details later, yeah? Okay, and the last thing that you need to know would be how to differentiate a function that involves sum and difference. So if your function comprises of a sub-functions, okay, for example, y equals to u plus v, what you need to do is, to differentiate it, you need to differentiate each one of the sub-function. Alright, so for example, if you have y equals to 16x plus 9x squared, so to differentiate it, you need to differentiate each of these components. So you need to differentiate 16x, which will give you 16, and you need to differentiate 9x squared, which you're going to end up to get 18x. Alright, I'm going to show you these 3 rules again in details by using another examples. Kita nak stop sekejap sebab yang ni saya kena masuk dalam words kot.
Berarti boleh buat kan?
Sekejap ya. So ni Mana dulu saya ulang balik lah kod the rules tu balik supaya dia senang sikit kot. Okay. Alright, let me show you in details about the rules of differentiation. Okay, so let me start with the power function rule because that is the basis for the other rules. Okay, now a power function is a function with an exponent. Okay, so we have here y equals to a x to the power of n. So a is a number, x is your independent variable, and n is your exponent. Okay, now if you want to differentiate the power function rule, there are 3 steps involved. If you follow these 3 steps, then you're going to be okay. Okay, so what's the first step? Well, the first step is you need to bring down the exponent. Okay, so to differentiate, okay, your function, so to differentiate your y function, okay, what you need to do is first of all bring down your exponent n. Okay, the second step, you need to write down the original function. What's the original function? A x to the power of n. Okay, so this is your original function. So that's the second step. Okay, now what's the third step? The third step is you need to reduce the exponent by 1 unit. And remember your exponent just now was n, so all you need to do is just reduce, okay, your exponent by 1 unit. Okay, so 3 steps involved. First of all, bring down your exponent n. Second step, write down your original function, which is ax to the power of n. And the last step, you need to reduce the exponent by 1 unit. Okay, so again, the first step, you need to bring down your exponent. Second step, you need to write down your original function, which is ax to the power of n. And the third step, you need to reduce your exponent by 1 unit. Okay, so let's try one example here. Okay, so let's say we have y equals to 3x to the power of 4. Okay, so let's enlarge this a bit. So we have 4 as an exponent. Okay, so this is your original function. Y equals to 3x to the power of 4. We want to differentiate this function, meaning that we want to find dy dx. So how are we going to differentiate the function? Remember the 3 steps. First of all, you need to bring down the exponent. And in this case, your exponent is equals to 4. Second step, you need to write down your original function. And in this case, your original function is 3x to the power of 4. Okay. And the last step that we need to do is we need to reduce the exponent by 1 unit. So simply minus 1 for your exponent. Now, if you look at this equation, it can be simplified further. So what you need to do is simply multiply this equation. Okay, so 4 times 3 is equals to 12, and you have x to the power of 4 minus 1, which is equals to 3. So you're going to end up having 12x to the power of 3. So this is how you differentiate a power function. Okay, so very simple, isn't it? So you would like to try another one? So let's say we have y equals to 0.5 x to the power of 3. Okay, so how do we differentiate this power function rule? Okay, so remember, we would like to differentiate the function, isn't it? So now what we need to do is we need to follow the 3 steps. The first step being you need to bring down the exponent. What's the exponent? It's 3. Okay. Next step, you need to write down the original function, which is 0.5 x to the power of 3. So that's your second step. And the last step requires you to reduce the exponent by 1 unit. So simply minus 1 for the exponent. And because you can simplify this further, so let us simplify it. Okay, so 3 times 0.5 will give you 1.5 x. Okay, so you just write x, and 3 minus 1 is equals to 2. So that is the derivative for y equals to 0.5x to the power of 3. Okay, so that's the power function rule. Now, next, let's look at the constant function rule. Okay, so just now I was saying, if you are given a constant function, okay, and if you want to differentiate it, okay, you're gonna get 0. Okay, so for example, y equals to 50. Okay, now we would like to differentiate the function, meaning that we would like to find dy dx. Okay, so what's the answer? The answer is automatically 0. Okay, or if let's say you have y equals to 20,000 and you want to find the derivative of the function, okay, so what's the answer? The answer is still 0. So as long as you differentiate a constant function, the answer is always 0. Okay, now another one thing that I would like to highlight here, so even though it's not given in the rules, is that if let's say you are given a straight line function, okay, so remember your linear function or your straight line function, so let's say you have y equals to 50x. Okay, let's say you want to differentiate the function. Okay, so if you differentiate, okay, a line function, you will get automatically 50. Okay, I give you another one. For example, let's say you have y equals to 0.25x. You want to find dy dx. The answer would be just the coefficient. Okay, now what's the reason for having only the coefficient? Okay, if you differentiate a line function, well, what you can do is remember the power function rule just now. Okay, if you have y equals to 0.25x, now what's the exponent just now? Okay, you see that there's no exponent here, right? So if there is no exponent being written here, understandably the exponent is equals to 1. Okay, so when you differentiate, okay, a power function rule, remember what you need to do is you need to bring down the exponent, which is 1, isn't it? Okay, and then you need to write down the original function, which is 0.25x. Okay, and you need to reduce the exponent by 1 unit. And as you know, okay, here you already have 1 minus 1, so that would be your exponent. So hang on. Okay, so it's the same, we still apply the power function rule. Okay, so you can see that we bring down the exponent 1, you write down the original function 0.25x to the power of 1, and you reduce the exponent by 1 unit. And if you simplify this, so 1 times 0.25 is 0.25 x to the power of 1 minus 1, it's 0, isn't it? So anything with 0 as an exponent is equals to 1. So you're going to end up getting 0.25. So that's why I said if you have y equals to 50x or y equals to 0.25x, if you want to differentiate it, your dy dx will be just the coefficient. Okay, so that's the shortcut. Alright, so even though there are 6 rules of differentiation, as I said just now, for this course you only need to know the first 3. Okay, how to differentiate a constant function, how to differentiate a power function, and how to differentiate a sum or a different function. So we haven't gone into that yet. Okay, so all I have shown you is how to differentiate the power function, how to differentiate a constant function, and I give you an additional one additional trick. If you are given a line function and you differentiate it, you simply get the number. Okay, now if you look at all this equation, it all involve just a very simple function, isn't it? But what if, okay, you have a function which looks something like this: y equals to 2x to the power of 3 minus 0.4x plus 20. So this function looks a bit complicated, isn't it? Okay, so all this while you were given a very short function, but now you have a mix of a power function, a line function, and also a constant function. So how do you differentiate this type of function? Now, if you are given a mixture of a subfunction, okay, to differentiate it, what you need to do is simply apply the rules that I have just shown you just now. So for example here, okay, we would like to find dy dx, or we would like to differentiate our function, our long function just now. So how are we going to do it? Okay, so to differentiate 2x to the power of 3, we need to use the power function rule. Okay. Alright. Now, to differentiate this function, we're going to start with the first subfunction. Okay, if we look at the first subfunction, okay, what we have here is a power function, isn't it? So if you have a power function, you need to use the power function rule to differentiate it. Okay, can you still recall, okay, what are the steps involved in differentiating a power function rule? So remember, you have to bring down your exponent, which is 3. Okay, the second step, we need to write down the original function, 2x to the power of 3. And what's the third step just now? Correct. The third step, you need to reduce the exponent by 1 unit. Okay, so that's how you differentiate the first subfunction. Okay, and then let's moving on to the second component. So the second component is negative 0.4x. Now remember, this is a line function, and what did I just say about the line function? So if you have a line function and you want to differentiate it, you will get the number. So in this case, the number is negative 0.4. Okay, and the last component is actually a constant. So every time you differentiate a constant, automatically you're going to get 0. Okay, so you have 0. So this function can be simplified further. Okay, so let's simplify it. So you're going to get 6x to the power of 2, okay, minus 0.4. So this is the derivative for the long function of y equals to 2x to the power of 3 minus 0.4x plus 20. Okay, so this is not a very difficult topic. Okay, all you need to know is the 3 steps just now. Okay, how to differentiate the power function rule, how to differentiate a constant function, and also how to differentiate a line function. If you know all these 3 things, then you're going to be okay with the differentiation.